We're going to solve quadratic equations by completing the square and using the quadratic formula. So here's the process to completing the square. First thing is we need it in correct form, which is ax squared plus bx plus c equals 0. A couple things to notice. 0 must be on the right side. Technically it doesn't have to be. The main thing is that ax squared and bx are on the same side, or on the left side, or the right side. But the c will eventually go back to the other side. But make sure we're looking at this form. Sometimes you got to multiply things out to get rid of the parentheses or eliminate fractions, things like that. If a doesn't equal 1, we're going to divide by a. For the purpose of this example, we're only going to use where a equals 1. Then we're going to move the c over to the other side. And then we're going to start the process of completing the square, which means we're going to add 1/2 b squared to both sides. That's the same thing as saying taking b over 2 and square it. And then we're going to factor. It's going to factor as a perfect square. In fact, it's always going to factor as x plus 1/2 b, quantity squared. And then we're going to use the square root property to solve. Sounds complicated, and it kind of is, but it's not the worst thing once you get the hang of it. So here we go. This is just an example of how to use this 1/2 b squared or the b over 2 squared. We want to think what number squared, or what number do we add to this expression so that's going to factor as the same thing times itself. And here's the process. We're going to take our b, which is 10, and we're going to divide that by 2, and we're going to square that answer. Well, what is 10 divided by 2? And you'll say 5. And when you square the 5, you get 25. So that's what you add to both sides. Now here's the reason why it factors that way, or is going to factor. Think of the full method backwards. First thing you look at is x squared. What times what is x squared? And you'll say x times x. Then jump to the 25, and you're thinking what times what is 25? That adds up to 10. Well, I start thinking 5 is associated with both those numbers. 5 times 5 is 25. 5 plus 5 is 10. So it's going to be 5 and 5. And that's how it factors, x plus 5 squared. That's what this means. It always factors as x and then plus 1/2 b. So 1/2 b we found was 5. So that's how it factors, x plus 5 squared. Let's do this next one. Take the b, which is negative 14. Divide that by 2, and we're going to square that. Well, negative 14 divided by 2 is negative 7 squared equals positive 49, because the negative times the negative is a positive. So it's 49. Well, how's it going to factor? That's a square. So it's going to be x, and then it's 1/2 b. So what's 1/2 b? Well, 1/2 b, half of negative 14 was negative 7. That's how it factors every single time. So now let's actually do some problems. Now we're going to the process. Here's our whole process. We have it in correct form, which means we now need to move this, and there's nothing in front of the x squared, so now we need to move that 7 over, so we're going to add 7 to both sides. And we have x squared plus 4x equals 7. Then we're going to take 1/2 b, in this case 4, either b, take 4 divided by 2. We're going to square that. We get 2 squared, which is 4. So we're going to add 4 to both sides. So here's our two sides so far. Now we're going to add 4. In fact, I want to do this, just so you can see. We added 4 to both sides. And now we're going to factor. This side is going to factor as x. What's 1/2 of 4? What's that 2? Plus 2. Then 7 plus 4 is 11. And then we're going to finish it by using the square root property. Which means to get rid of the exponent of 2, we square root both sides. The only thing you must remember is plus or minus. So this square root and this square cancel, leaving x plus 2. And over here we have plus or minus the square of 11. To get the x by itself, we subtract 2. I want to see where I can move. I don't want to move down there. So let's just go over here. We have x equals -2 plus or minus square root of 11. Now if you want to rewrite it by separating the plus and minus, it'd be -2 plus square root of 11 and -2 minus square root of 11. And that's it. Let's do this one. Now, it is true I don't have the 4 on the left side. I have it in the correct form, but the thing is, I'll end up moving the 4 back over, so I'm just going to leave it over there. There's nothing in front of the x squared. So all I need to do now is find what I need to add to both sides. So I'll take half of -8. So I'll square that. Half of -8 is -4. And when you square that, you get 16. So we're going to add 16 to both sides. And this is going to factor as x, and then half of -8 is -4. So it factors as x minus 4 squared equals 20. And to finish this, we get rid of the exponent of 2 by square rooting both sides. Don't forget the plus and minus. So we end up with x minus 4 equals plus or minus the square root of 20. Now we need to break down or simplify the square root of 20. And if you need some help with that, you can always use your calculator. You can always type in y equals 20 divided by x and look at the table. And we're looking for pairs of numbers that give us 20. So we have 1 and 20, 2 and 10, 4 and 5. I want to use 4 and 5. And the reason why I'm using 4 and 5 is the 4 comes out as, the square root of 4 is 2, and the 5 stays. Then we need to get the x by itself, so we're going to add 4 to both sides. We get x equals, and we'll write the 4 first, 4 plus or minus 2 square root of 5, which is the same thing as 4 plus 2 square root of 5, and 4 minus 2 square root of 5. Now, we can also use the quadratic formula, and this is just a standard formula. It never changes. A, B, and C are, when you have to put in correct form. Ax squared plus bx plus c equals 0 form, no matter what. A is the number in front of the x squared, B is in front of the x, and c is the constant. So, let's solve these by using the quadratic formula. What we need to do first is determine what A, B, and C are. A is in front of the x squared, so that's a 1. B is 5, and C is 2. So I'm using the quadratic formula. And watch how I do this. And you will be using this quite a bit, especially when it comes to finding zeros of polynomials in your college algebra class. So let's look. We got B and B. So B is 5, so that's 5. That's 5. A goes next, that's 1. C comes next, which is 2. A is on the bottom, which is 1. So now we just clean it up. So we have a -5 here. 2 is on the bottom. So we pretty much got to clean up the radical. So 5 squared is 25. 4 times 1 is 4, times 2 is 8. So we have 25 minus 8. We end up with -5 plus or minus the square root of 17 over 2. Now that may be good enough as the answer. It all depends on the system you're using. You can also do this. You can rewrite it as -5 over 2 plus or minus the square root of 17 over 2. Each one of these is being divided by 2. And you can also write it like this. -5 halves plus square root of 17 over 2, and also -5 halves minus square root of 17 over 2. See this one. Do the same process. A is 4, B is, don't forget that sign, -7, C is 2. Using the formula, I'm just going to rewrite it with empty parentheses. That first one's meant to be a parentheses. Let me erase that. So this is b. Make sure you got that negative 7 in there. Negative 7. And make sure you use parentheses. 4, 2, 4. And the reason why I'm using parentheses is because here, negative and negative makes that a positive. 2 times 4 is 8 on the bottom. And here, if you type it in your graphing calculator, make sure you use parentheses when you type it in, because you better get a positive value. Anything squared is positive. It's only a negative if there's no parentheses or if it's negative signs on the outside. 4 times 4 is 16. 16 times 12, big number, 168. Equals 7 plus or minus. 49 minus 68 is the square root of 121, and that is a negative. I need some space in there. I need space. Negative 121. Let's make sure. No, it's not either. It's negative 119. Now the last thing is we have a minus sign underneath, and we don't want a minus sign underneath. So that minus sign is going to come out as imaginary. You can get imaginary numbers in your answer, so be aware of that. 119, I don't think it breaks down, so we'll just do some checking. First off, let's just make sure. 49 minus 119, never hurts to check. Now, what am I doing? 49 minus 168. Negative 119. I'm going to go and type in 119 divided by x. This little table trick does make life a lot easier for you. So I'm just looking, and it looks, well, 7 times 17. Neither one of those will break down. So it's not going to break down anymore. So the only thing that's simplified, there's 17 times 7 again. The only thing that's simplified was the minus sign came out as an I. So from here, I can separate plus or minus, and I can divide each of those by 8. So I get 7 over 8 plus or minus I square root of 119 over 8, which equals the same as 7 over 8 plus I square root of 119 over 8, and also 7 over 8 minus I square root of 119 over 8. That's a pretty tough one right there, but that's it.